Okay, so the first thing that I'm going to go through is your multiplication property. And in class you got the actual property, and it says that if the same bases are being multiplied, you're going to add the exponents. So in the problem that I have here, 3 is the base. And so all I'm going to do is add the 5 and the 2, and you have 5 plus 2 equals 7. So you end up with 3 to the power of 7. But let's talk about why that happens and why that can give you that result. Let's say I have a to the power of 4 times a to the power of 2. And write this on your dry erase board as I'm going through these. So a to the power of 4, what does that really mean I'm doing?
A to the power of 6.
Okay, good, but before we get to that point, I want you to break it down. I want to like totally step this down to like all of the basic little parts. So what does a to the power of 4 really mean?
Multiplying a 4 times by itself.
Okay, so that means I'm doing a times a times a times a. That's a to the power of 4. And then I have a to the power of 2, which means a times a. So why are we adding these two exponents? Well, how many total a's do you have there? 6. So if I do 4 plus 2, that gives me a to the power of 6. Question.
So you have like a times a times a times a, and then another a times a.
Mm-hmm.
How do you get that?
There's a multiplication symbol between them. So that going back to that rule, the way it's stated, if the same bases are being multiplied. Now, if you see an addition symbol, then you cannot do this. Then this rule does not apply.
So you just leave it the way it is.
Mm-hmm. Then you're going to have to do. Then we go into combining like terms, and that's going to come up in a little bit in the future, in the next week or two. Okay, so let's do another one together. I have p to the power of 4 times x to the second power times p. Now, if you're expanding it, that's fine, but I don't think that we need to expand it now. I think that you kind of get where it's going. When you have your final answer, simplify. Let me see it. Good, and I see most of you have p to the power of 5 times x to the power of 2. Technically, I don't even need to write that. I could just put p, 5, x, 2. I don't even need to put the symbol. Because when they're next to each other, the symbols means multiply. Okay, let's try another one. I have a to the power of 3 times a to the power of negative 6 times a to the power of negative 2. Simplify it. Let me see your results whenever you get it. Don't erase it yet. Okay. So one thing that I'm going to make sure, and I see some of you guys doing this, one thing I want you to make sure is that you remember the simplified rules. Your answer is simplified if, and I'm seeing one thing that's on here that y'all are doing, good, you cannot have any negative exponents. So if you gave me an answer with a negative exponent, go back and fix it. And if you did not, then you did it correctly, and I see those. Very good. So my answer is, very good, 1 over a to the power of 5. So it was a to the power of negative 5, but that negative 5 needs to go to the opposite level, the denominator spot.
So we went to negative exponents?
So before you did this, it was a to the power of negative 5. You're not allowed to have negative exponents.
I'm just not sure what to do with negative exponents.
You just move it to the opposite level. And once you move it to the opposite level, it becomes positive. So right here, if you have nothing, like if you don't have a fraction, then it's really over 1. So really that's on the top. So to make it positive, you have to move it to the bottom. Yeah, and denominator will become the numerator if it's negative on the bottom. Let's do one of those. Let's see. All right, I'm going to go into that division really quick. Talk about division real fast. Your rule for division is, your division property rule states that if you have the same bases, if they're being divided, if the bases are being divided, then you're going to subtract your exponents. So here in this problem, I have a 3 and I have a 3. They're being divided, but my exponent is 8 and 2, so I'm going to subtract the numerator exponent minus the denominator exponent. And that's usually a question that people ask. Does it matter which one goes first? Yes, it does. Numerator exponent minus the denominator exponent. Let's talk about why this works. So I have, let's do 5 to the power of 4 over 5 to the power of 3. Automatically, you're going to tell me it's what? 5. Or 5 to the power of 1, which is just 5. So why does this work? I'm going to expand it. 5 to the 4th power means 5 times 5 times 5 times 5. And you can just watch this. You don't have to write it out expanded. Over 5 cubed gives me 5 times 5 times 5. What is 5 over 5?
1.
Okay, so they literally cancel out. What are you left with?
5.
5. And that's why you have just 1 5 left on top. Okay? Which is 5 over 1, which is just 5. Okay? Let's do another one. I have 3 to the power of 2 over 3 to the power of 7. Okay?
Would you simplify it?
You're good.
Wait, you wouldn't simplify this?
Let me talk about that. So if I expand this, I have 3 times 3 on top, then I have 3 times 3 times 3 times 3 times 3 times 3. 1, 2, 3, 4, 5, 6 times 3. And I have to simplify the 3's. I don't have anything left up top, so what do I need to put in that placeholder? 1. So I really now have 1 over, how many 3's on bottom?
5.
3 to the 5th power. Now, if I were to subtract this, that would have given me 3. 2 minus 7, that would have given me 3 to the power of negative 5. Why am I not writing it like that?
You have a negative exponent.
No negative exponent. Very good. All right. Let's try a few really quick on your own at your boards. I have x to the power of 2, y to the power of 3 over x to the power of 5, y to the power of 1. You don't have to put anything. Y. Hold up your boards when you have it simplified.